Hello everyone. In this video we will discuss about the polymerization reactions. So this is a very important practical applications that we use every day of our life. Well, technically you don't do the reactions, but you use the product every day. So let's talk about the polythene, the plastic bag that you use in the grocery stores. So what is it? So it is a polymer of some alkene. So what is the alkene? So I'm gonna start here. So first one is the polythene. So that's the nickname, but actually it's a polymer of ethene. So it's a polymer of ethene. So if you look at the structure of ethene, what is the structure of ethene? It is CH. Ethene is two carbon atom, right? So it's CH2 and CH2. So if you look at each bond is made up of two electrons, right? So that means right here we have how many electrons? Four electrons right here in between two carbon atoms, because it's a double bond, so they are sharing four electrons. So technically what happened in the polymerization reactions, so this one single unit, so this is one unit is called one monomer. So one monomer reacts with multiple. So like think it this way, it's like a brick wall, or not a brick wall. Like I think the better example would be a train with infinity distance, where one after another is getting attached. So you don't need to focus that much into reaction. So let me redraw this. So we just need to appreciate how polymers are being made. So now one electron can move to this side, the other electron can move to this side. So what would happen if there is another ethene molecule, which is right there, and it also has those extra two electrons. So one of them would go here, one of them would go here. So if there is another one right next to it, so one of them would go here, one of them would go here. So as a result, what you are getting is, so this is the polymerization reactions. So what you're getting is, I'm gonna color code this time better. So what you're getting is C H H. Now double bond is broken, so now it's gonna attach on this side with the next pink carbon atom. So this is the pink one. This is really easy once you grasp the concept of polymerization reactions. And the last one was blue, so CH, CH, CH. Okay, so on this side, it's gonna keep growing on this side. It will also keep growing on this side, right? So you got the idea. So our one unit, which was CH2, CH2, that whole thing is being repeated one after another. So you're attaching train. It's like one box of train. Well, what do you call it? Box, or what's the word? One boggy. Boggy? Oh, I'm not sure. Okay, so it's the train, one unit of the train, like one piece of box. So it's keep getting repeated over and over. So it doesn't matter what attached to these two carbon atom, right? So it doesn't matter what attached to this carbon atom. I could change this here to something else and you'll make a totally different polymer. And that's pretty much what happened in the polymerization reactions. Okay, again, so what is the name of this compound? It's called polythene. So this is used in our plastic bags and a bunch of other things like plastic bottles, insulations. Um, so when you write the polymerization reaction, this is how we write. So you can simply write like this: C H H C H, H. So this is the 1 unit, and then you extend on both sides and then put a bracket and then put N. So N means it's the same unit is keep getting repeated on either side. So instead of writing the multiple structures, we write like this. So that's our polythene. So let's see another example. Have you heard about the PVC pipe? PVC pipe, the one we use in our house every day, everywhere. So PVC. So this is called polyvinyl chloride. Okay, so polyvinyl chloride is a polymer of vinyl chloride. Vinyl chloride is a nickname of the compound. Again, its molecule is pretty simple. So it's CH2 CHCl. If I want to extend this, maybe I should write in the extended format. So CH2, and that is vinyl chloride, right? Vinyl chloride. So this is the nickname. What should be the its actual name? The IUPAC name, systematic name. Systematic name is, it has 2 carbon atoms, so it's gonna be eth. It has 1 double bond, so it's gonna be ethene. Then it has a chloro substituent, so it's gonna be chloroethene. Okay, so when we do polymerizations reactions for this one, again the principle is exactly the same. So the double bond will be gone and the carbon chain would extend on either direction. So you will get nothing changes here, nothing changes here, nothing changes here. Well, double bond is converted into single bond because those electrons are used to extend. Nothing changes here, chlorine, chlorine stays, hydrogen, hydrogen stays same. But what we do is we get extended structure, which is our PVC pipe, polyvinyl chloride. All right, so it's pretty simple. Like, you will be asked in the homework and exams, what would be the polymer of this particular compound. So you just need to know how to draw it out. So if it asks draw 2, draw 2. If it asks draw 3, draw 3, draw 3 units. All right, so next, another one we're gonna be learned about is Teflon. Teflon. Why do we use Teflon? Teflon is used in our non-stick pots, right? So it is a polymer of tetrafluoroethene. So Teflon is used in our cooking non-stick pans, right? So we all know non-stick pan, although we have now better coating. So this is old school way. Okay, Teflon used to use, so it is a same, the canonical structure is same, but this time instead of hydrogen, it has all the hydrogen are replaced by fluorine. So this is the structure. The parent name is ethene, and it is replaced by 4-fluoro. So it's called tetrafluoroethene. So E should be small letter because it's one word. E-T-H-E-N-E, tetrafluoroethene. So what should be the polymer of the tetrafluoroethene? It is the exact same way. C, single bond C. Everything is fluorine, 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 and things would get extended on either side. Just remember, this thing is keep getting repeated infinity times. Like, as long as you have materials, it will be keep repeating over and over. All right, let's do one last, which is our plastic cups, the coffee cups, the styrofoam. So it's made up of polystyrene. Uh, Polystyrene. So again, the basic structure is exactly the same, C double bond C. We have hydrogens, 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 and hydrogens, but one of them here is replaced by a compound called benzene ring. So we're gonna learn next on this video what is a benzene ring. So that's the polystyrene. So you do polymerizations reactions here, and what would you found out? So you found out that the polymer is gonna look like this, and everything else stays the same, and you get this polystyrenes. All right, so that's our polystyrenes. It used in our coffee cups, plastic insulation, so it's styrofoam basically. All right, so that's pretty much all about the polymerizations reactions. Only last thing I'm going to talk about in this video, which is aromatic compound. I'm just going to give you a brief introductions here. Uh, and we will learn about more about this as we go along. So obviously aromatic compound, aromatic is nice smelling, that's what we call it, aromatic. So in the early 1800 centuries, few of the chemists, they found that some of the herbs contains a special compounds, and all of those special compounds have a structure that looks something like this. So what is it? So it has 6 carbon atom, and all of these carbon atoms are connected by double bonds. So you see the double bonds? So these are alternate double bonds. So let's do an expanded structure, see how it looks like. So we have, so remember this is not a cyclohexane, because cyclohexane is all single bonds, right? Okay, so we got 6 carbon atoms now. Okay, 1, 2, 3, 4, 5, 6, and each of them are connected by alternate double bonds. Okay, so now how many hydrogen do we need? Okay, let's look at this one. This carbon atom has 1, 2, 3 bonds. So every carbon atom should have 4 bonds. So to make it 4, we need 1 hydrogen. So if you notice, everywhere we just need 1 hydrogens. So this molecule is called benzene. So all the aromatic compounds, in simple terms, like very basics rule, it should have a benzene ring, and the benzene ring can be extended by removing 1 hydrogen. So if you can remove 1 hydrogen, then you can attach anything here you want. Again, you don't have to remove 1 hydrogen, you can remove multiple hydrogen and you can attach anything. So there will be a lot of aromatic compounds which are going to be benzene derivatives, so which is made of, but the core structure is like this. So again, the double bond here is not localized. The double bond can be alternate. It's called resonance structure, which you will learn in your future classes, not the scope in this course. So you can see I moved the double bond to the next. So I move this double bond to the next bond here. So now you got the double bond. So overall, so this double bond can be anywhere between there. So that's why people write the structure of benzene ring like this. So this is cyclohexane, then you put a circle in between. So when you put a circle in between, that becomes benzene. So this tells us the circle represents that the double bond could be anywhere in here. Okay, so that's about the benzene ring. That's all you want to focus on here. We will, as we go along in the future chapters, we will learn more about this in the future chapters. Let's stop here.